The universe looks calm from a distance, but that calm is misleading. What appears to be scattered light is actually a vast, organized system in motion, where galaxies drift, gather, separate, and evolve according to rules written long before stars existed. When astronomers began mapping these galaxies in 3 dimensions, they uncovered something unexpected, a hidden structure stretching across hundreds of millions of light years, linking clusters through immense cosmic pathways, while leaving enormous regions almost empty. This structure wasn't designed, yet it shapes where galaxies form and how they move, guiding matter along invisible routes through space. Some galaxies collide and merge, others travel in slow, silent streams, all influenced by forces we still struggle to fully understand. And to make sense of this immense system, to see how it all fits together, let's start with our home, the Milky Way, a massive spiral of stars, gas and dust spinning through the darkness of space. And this galaxy is your cosmic address. Everything you have ever known, everyone who has ever lived, every war fought, every love story written, every discovery made. All of it happened here, inside this one structure. The Milky Way stretches across 100,000 light years. Imagine that. Light, travelling at 300,000 kilometers per second, takes 100,000 years just to cross from one edge to the other. Inside this vast spiral, there are more than 400 billion stars, some smaller than our Sun, some hundreds of times larger, and around many of those stars, planets orbit in silence. Our Sun is not special. It sits in a quiet outer arm of the galaxy, far from the chaos at the centre. We are in the suburbs of the Milky Way, a safe distance from the violence that churns at its heart, because at the centre of our galaxy, something monstrous waits, a supermassive black hole, 4 million times the mass of our Sun. It does not shine, it does not make sound, but its gravity is so immense that stars orbit around it at thousands of kilometers per second. This black hole has been there for billions of years, silently ruling the galaxy. The Milky Way spins like a cosmic disk. It rotates slowly, taking about 200 million years to complete one full turn. Our Sun has only made 20 trips around the galaxy since it was born. Dinosaurs walked the Earth the last time we were on the opposite side. From where we stand, the galaxy feels infinite. The night sky is full of stars, and it seems like they go on forever. But step outside, look at the Milky Way from a distance. Suddenly it is just one spiral among trillions, a single island of light floating in an ocean of darkness. This is where your journey begins. This is home, and it is already unimaginably tiny. But the universe does not stop here, because the Milky Way is not alone. It has neighbours, and those neighbours are coming closer. You just learned that the Milky Way is home. But here is the truth. We are not alone. Our galaxy exists inside a cosmic neighbourhood called the local group, and this neighbourhood is crowded. More than 54 galaxies live here, all bound together by gravity. Some are massive spirals like ours, others are tiny dwarf galaxies, barely holding themselves together. But they all share the same space. They all feel the same gravitational pull, and among them, one galaxy dominates, Andromeda. Andromeda is the largest galaxy in the local group. It is twice the size of the Milky Way and contains over 1 trillion stars. If you look up at the night sky on a clear evening, you can see it, a faint smudge of light. But that smudge is an entire galaxy, 1 trillion suns packed into a spiral bigger than anything near us. Now here is where it gets strange. Andromeda is not sitting still. It is moving, racing through space at 250,000 miles per hour. And it is heading straight toward us. In about 4 billion years, Andromeda and the Milky Way will collide. Let that sink in. 2 galaxies, each containing hundreds of billions of stars rushing toward each other. The collision will be slow by human standards. It will take millions of years to complete, but when it happens, everything will change. You might think the stars will crash into each other, but space is so vast, so empty, that almost no stars will actually touch. Instead, the galaxies will pass through one another like ghosts. Their shapes will warp, their spiral arms will stretch and tear, gas clouds will collide, igniting waves of new star formation. The night sky will blaze with young blue stars being born from the chaos. And at the center of it all, two supermassive black holes will spiral inward, closer and closer, until they merge into one. The resulting shockwave will ripple through space-time itself. When the collision ends, neither galaxy will exist anymore. In their place will be a new galaxy. Scientists already have a name for it: Milky Way. But even this dramatic event is small, because the local group is just one cluster, one tiny collection of galaxies, and beyond it, something far larger is pulling, something we cannot see, something that governs the motion of 100,000 galaxies. What could be that powerful? Something is pulling us. You might think galaxies drift randomly through space, that they float wherever gravity takes them, but that is not what we see. Galaxies are not wandering, they are flowing, moving together in massive streams, all heading in the same direction, and scientists discovered something terrifying. Our galaxy, Andromeda, the entire local group, and tens of thousands of other galaxies are all being pulled toward a single point in space, a region so dense, so gravitationally powerful that nothing in its vicinity can escape its influence. They call it the Great Attractor. The Great Attractor sits 150 million light-years away from us. That is so far that the light we see from it today left before dinosaurs evolved on Earth. But despite that distance, its gravity reaches across the void and pulls us toward it. Not just us. Over 100,000 galaxies are falling toward this cosmic monster. Here is the strangest part: we cannot see it. The Great Attractor is hidden behind the plane of the Milky Way. Thick clouds of galactic dust block our view. We know it is there not because we can observe it directly, but because we can measure its effect. Galaxies near it move differently. Their velocities change, they accelerate, and when astronomers mapped those motions, they realized everything in our region of space is being dragged toward the same spot. Imagine standing in a river. You cannot see where the water is flowing, but you feel the current pulling you downstream. That is what is happening to our galaxy right now. We are caught in a cosmic current, and we have been traveling along it for billions of years without knowing. But what is the Great Attractor exactly? Is it a single massive galaxy? A cluster of galaxies? Something even larger? The answer is more complex. It is not just one object. It is a region where matter has concentrated so densely that its gravity warps space itself. Superclusters of galaxies pile up there. Dark matter gathers, and together they create a gravitational well so deep that everything nearby falls into it. Space is not static. It flows like water, and galaxies are riding currents we are only beginning to understand. But the Great Attractor is not the end. It is part of something even bigger. A structure so vast it makes everything we have talked about seem microscopic. What could be larger than this? You now know something is pulling us. But where does that pull come from? What structure could be so immense that it governs the motion of 100,000 galaxies? The answer is Laniakea. Laniakea is our supercluster, a collection of galaxy clusters so vast that it spans 520 million light-years. To cross it at the speed of light would take longer than complex life has existed on Earth. And inside this supercluster there are 100,000 galaxies, each one a universe of stars, each one containing billions of worlds. The Milky Way is just one tiny dot inside Laniakea. The local group is invisible at this scale. Even the Great Attractor, that gravitational monster pulling everything toward it, is just one feature among many. Laniakea is the true cosmic home we belong to. But Laniakea is not a random collection of galaxies scattered through space. It has structure, and that structure is beautiful. Galaxies do not float alone. They form filaments, long threads of matter stretching across hundreds of millions of light-years. These filaments connect massive galaxy clusters like veins in a body, and when you map them, something incredible appears. The universe looks like a neural network. Threads of galaxies branch and connect. Clusters form at the intersections, and everything flows along these pathways. This is called the cosmic web. Matter is not evenly spread through space. Gravity pulls it into dense regions. Gas collapses, stars form, galaxies ignite, and those galaxies gather along the filaments. They flow through the cosmic web like blood through veins. Nothing is placed randomly. Everything follows gravity's blueprint. At the largest scales, the universe has a skeleton, and we are living inside it. But here is what makes it even stranger. The cosmic web is not unique to our region. It repeats everywhere. No matter where you look in the universe, you see the same pattern. Filaments, clusters, superclusters, all woven together into a vast web of light. The universe is organized, structured, shaped by forces we're only beginning to understand. But the cosmic web is not complete, because between the filaments, something else exists. Regions where galaxies do not live, places where almost nothing exists at all. These are the voids, and they are terrifying. You have seen where galaxies live. Now let me show you where they do not. Between the filaments of the cosmic web, there are vast, empty regions, places where galaxies simply do not exist. We call them voids. And they dominate the universe. 80% of the universe is empty space, not the kind of emptiness you imagine. True emptiness. Regions so devoid of matter that if you were placed inside one, you would see almost nothing. No stars, no galaxies, just darkness stretching in every direction for hundreds of millions of light years. Some voids are 300 million light years across. Imagine that scale. A sphere of nothingness so large that even light, travelling for 300 million years, would still be inside it. These voids are not rare. They are everywhere. The universe is filled with them. But how do voids form? Why does matter avoid these regions? The answer lies in gravity. When the universe was young, matter was spread almost evenly, but gravity amplifies tiny differences. Denser regions pulled in more matter. They grew into filaments and clusters, and as matter flowed toward these dense regions, it evacuated the spaces in between. The voids were born. Now, billions of years later, the voids remain, and they continue to grow. As galaxies flow along the cosmic web, the voids expand. Matter keeps leaving. The emptiness deepens. Galaxies only exist on the edges of voids. They cling to the boundaries where filaments meet. Inside the voids, there is almost nothing. Occasionally, a small dwarf galaxy drifts through, but it is alone, isolated, cut off from the cosmic web. The voids are colder than the rest of space. Without galaxies to heat the gas, without stars to radiate light, the temperature inside a void drops. It becomes one of the coldest places in the universe, a frozen desert of darkness. And here is the most unsettling part. The voids are the future of the universe. As expansion continues, galaxies will drift farther apart. The filaments will stretch, and eventually most of the universe will look like a void, empty, dark, silent. Right now, we live in a golden age, an era where galaxies are close enough to see, where stars shine brightly, where structure still exists. But that will not last forever. Darkness is the universe's natural state. But before we lose ourselves in that cold future, let us return to the present. Because right now, galaxies are not drifting peacefully. They are colliding, and those collisions are building the universe. Galaxies are not peaceful. They collide constantly. You might imagine space as calm and orderly, stars drifting quietly through the void. But the reality is violent. Galaxies crash into each other with unimaginable force, and when they do, the universe transforms. These collisions happen slowly by human standards. A single collision takes millions of years to complete. But in cosmic time, they are frequent. Right now, somewhere in the observable universe, thousands of galaxies are colliding. When two galaxies meet, their stars do not actually hit each other. Space is so vast that stars pass through like ghosts, missing one another entirely. But the gas clouds do collide, and when gas clouds slam together at thousands of kilometers per second, they compress. Heat builds, pressure rises, and suddenly stars begin forming at an explosive rate. These are called starburst galaxies, regions where millions of stars ignite in a cosmic fireworks display. The collision triggers so much star formation that the galaxy shines 100 times brighter than normal. New stars flood the darkness with light, but the collision does more than create stars. It reshapes the galaxies themselves. Spiral arms get torn apart, disks warp and stretch. The elegant structures that took billions of years to form are destroyed in moments. And when the chaos ends, what remains is often an elliptical galaxy, a massive sphere of old stars with no structure left. At the center of each colliding galaxy is a supermassive black hole, and as the galaxies merge, those black holes spiral inward, closer and closer, until finally they collide. When two supermassive black holes merge, they release gravitational waves, ripples in space-time itself. These waves travel across the universe at the speed of light, carrying the memory of that violent event. We have detected these waves. We have felt the echoes of ancient collisions that happened billions of years ago. But not all collisions end quietly. Sometimes the black holes at the center of merging galaxies begin feeding. Gas pours into them, and as matter spirals into the black hole, it heats to millions of degrees. It glows brighter than entire galaxies. These are quasars. Quasars are the brightest objects in the universe. A single quasar can outshine 1 trillion stars. They blast radiation across space, lighting up the cosmos. And they are born from destruction. Galaxy collisions are not accidents. They are how galaxies grow. The Milky Way has consumed smaller galaxies before. Their stars now orbit inside us, remnants of past conquests. And in 4 billion years, we will merge with Andromeda. Creation follows chaos. Structure emerges from violence. But to understand this fully, we need to step back even further. Because looking far into space means looking back in time. Here is something that will change how you see the universe. When you look into space, you are looking into the past. Light does not travel instantly. It moves at 300,000 kilometers per second, fast by human standards. But across cosmic distances, even light takes time, and that means everything you see in the night sky is old. You're not seeing the universe as it is. You are seeing it as it was. Look at the moon. The light you see left its surface 1 second ago. You are seeing the moon as it was 1 second in the past. Now look at the sun. That light took 8 minutes to reach you. When you watch the sun rise, you are seeing the sun as it looked 8 minutes earlier. If the sun vanished right now, you would not know for 8 minutes. The light is already on its way. Now go farther. Look at the nearest star, Proxima Centauri. The light from that star takes 4 years to reach Earth. You are seeing it as it was 4 years ago. It might have exploded yesterday, and you would not know yet. The light from that explosion is still travelling toward us. Andromeda, our neighbouring galaxy, is 2.5 million light-years away. When you look at Andromeda, you are seeing it as it existed 2.5 million years ago, before humans evolved, before our ancestors walked upright. The light you see tonight started its journey long before civilization began. The farther you look, the deeper into the past you see. Distant galaxies appear as they were billions of years ago. Some of the galaxies we observe today no longer exist. They have collided, merged, or been torn apart. But their light is still reaching us, carrying the image of a galaxy that died long ago. Space is a time machine. Telescopes are not just tools for seeing far, they are devices for looking backward through time. And when astronomers look at the most distant galaxies, they see something incredible. The early universe was chaos. Galaxies were smaller, brighter, more violent. Star formation was everywhere. Collisions were constant. The cosmic web was just beginning to form. Everything was younger, hotter, more energetic. The universe has aged since then. It has cooled, expanded, matured. And we are witnessing that evolution by looking across distances so vast that time itself bends. Every observation of deep space is archaeology. We are studying the ancient universe, reading its history written in light. But among all those ancient galaxies, something stands out. The sheer number of them. Because galaxies are not rare. They are everywhere. You have journeyed far. You have seen our galaxy, our neighbours, the pull of the great attractor, the structure of the cosmic web, the emptiness of the voids, and the violence of collisions. But now, step back one more time. Look at the full picture. The universe contains over 2 trillion galaxies. 2 trillion, each one a collection of millions, billions, or even trillions of stars. Each one its own island of light. Each one a universe unto itself. And they fill the cosmos endlessly. Galaxies come in different forms. Spiral galaxies like the Milky Way have elegant arms that curve outward. These arms are filled with gas, dust, and young stars. Star formation happens constantly in spiral galaxies. They are alive with light. Then there are elliptical galaxies. These are older, quieter. They contain mostly ancient stars that have already exhausted their fuel. Elliptical galaxies are massive. Some contain trillions of stars. But they no longer create new ones. They are cosmic cities that have stopped growing. And then there are irregular galaxies. These are chaotic, torn apart by gravitational forces, often the result of collisions. They have no clear structure, no symmetry, just clouds of stars scattered through space. Some galaxies are 10 times larger than the Milky Way, giants that dominate their surroundings. Others are tiny dwarf galaxies with only a few million stars, barely holding themselves together. But galaxies do not exist alone. They live in communities, small groups like our local group, massive clusters containing thousands of galaxies, and those clusters form superclusters, structures so vast they dwarf anything we can comprehend. The gravity between galaxies binds them together. They orbit one another, they merge, they interact, and through those interactions they evolve. When you look at deep space images, every bright dot is not a star. It is a galaxy, hundreds of billions of stars compressed into a single point of light, and there are billions of these dots scattered across the sky. The night sky does not show stars, it hides galaxies. Each galaxy contains its own story, its own history of formation, growth, collision, and evolution. Some galaxies are quiet and stable, others are violent and active. Some are being torn apart by neighbours, others are consuming smaller galaxies to grow, and the universe is filled with them endlessly. Everywhere you look, galaxies stretch into the distance, layer upon layer, deeper and deeper, until the light becomes so faint we can barely see it. But those galaxies are not frozen. They are moving, evolving, and their motion reveals something extraordinary about how the universe works. Galaxies are not drifting aimlessly. They are moving with purpose, flowing along invisible highways that stretch across the universe. These highways are the cosmic filaments you learned about earlier, threads of matter connecting galaxy clusters, and galaxies follow these threads like rivers flowing downhill. They travel at millions of kilometers per hour, racing along paths carved by gravity. Entire galaxies move together in streams, hundreds of them flowing in the same direction, pulled by the same forces, following the same routes through space. This is not random motion, this is organized flow. The universe has currents and galaxies ride them. But when galaxies meet along these highways, something spectacular happens. They collide, and these collisions are not gentle. When 2 galaxies approach each other, their gravity begins to interact. They pull on each other, distort each other. Their shapes warp, and as they get closer, the collision triggers an explosion of star formation. Gas clouds inside the galaxies compress. New stars ignite by the millions. The galaxies light up in brilliant blue light. These are starburst galaxies, regions where creation happens at a furious pace. In just a few million years, more stars form than would normally appear in a billion. Some collisions activate the supermassive black holes at the centers of galaxies. Matter pours into these black holes, and as it spirals inward, it heats to unimaginable temperatures. The black hole begins to feed, and when a supermassive black hole feeds, it becomes a quasar. A quasar is the brightest object in the universe. It can outshine its entire galaxy. A single point of light so intense it can be seen across billions of light years. Quasars are born from chaos. They are the result of galaxies colliding and black holes consuming everything around them. But not all collisions create starbursts or quasars. Some simply transform galaxies. Spiral galaxies lose their structure. Their elegant arms get torn apart. And what emerges from the wreckage is an elliptical galaxy. A smooth sphere of stars with no rotation, no arms. Just old stars drifting in a cloud. Galaxies grow through destruction. The Milky Way has eaten smaller galaxies before. Their stars now orbit inside us, absorbed, integrated, lost in the larger structure, and Andromeda is on a collision course with us. In 4 billion years, we will merge, and a new galaxy will be born from the violence. Galaxy evolution is not peaceful, it is brutal. Creation follows chaos, and the universe is built through constant collision and transformation. But zoom out one final time, because these collisions are not isolated events. They are part of something larger. You started inside the Milky Way, one galaxy among trillions. Now you stand at the edge of understanding, looking at the full design of the universe. Galaxies are not the decoration of the cosmos. They are the building blocks. Everything in the universe is made from galaxies. They form the foundation of all structure. Galaxies gather into clusters. Dozens or hundreds of galaxies bound together by gravity. These clusters are massive. Some contain thousands of galaxies orbiting a common center, and the gravity holding them together is so strong that even light bends around them. But clusters do not exist alone. They form superclusters, collections of galaxy clusters stretching across hundreds of millions of light years. Laniakea, our supercluster, is just one of many, and these superclusters arrange themselves into filaments. The filaments are the threads of the cosmic web. They stretch for hundreds of millions of light years, connecting superclusters, linking galaxy clusters, creating a network that spans the entire observable universe. And galaxies sit along these filaments like beads on a string. Between the filaments are the voids, vast empty regions where galaxies do not exist. The voids and filaments together create a pattern, a structure that repeats at every scale. Small clusters mirror large superclusters. The same forces shape everything. Every galaxy follows gravity's blueprint. They orbit, they rotate, they collide, and through those collisions, they evolve. Nothing in the universe is truly still. Motion is constant, change is inevitable. Galaxies form from clouds of gas in the early universe. Gravity pulls the gas together. Stars ignite, and over billions of years those stars organize into spirals, ellipticals, and irregularities. The shapes we see today are the result of billions of years of evolution. But that evolution is not random. It follows rules, patterns. The rotation of a galaxy determines its shape. The density of matter around it determines how fast it grows. And collisions reshape everything. The universe evolves through galaxy interaction. Small galaxies merge into larger ones. Spirals collide and become ellipticals. Starburst galaxies ignite and fade. And quasars blaze for a time before dying out. Everything transforms. At the largest scales, the universe is written in galaxies. They carry the history of cosmic evolution. They show us how matter organizes itself, how gravity shapes structure, how chaos creates order. Stars make light, but galaxies give that light meaning. They organize it, structure it, turn it into something grander than individual suns burning in isolation. And now you understand. The universe is not a collection of stars. It is a kingdom of galaxies, and you live inside one of them, a traveller on a spiral arm, witnessing the grand design from within.